You know all this incredible AI we use every single day? Well, most of it is actually built from the same handful of core ideas. So in this explainer, we're going to pull back the curtain on the 9 essential concepts that you'll find in pretty much every modern AI system. Let's get right into it.
I mean, we all use these tools, right? But have you ever actually stopped to think about what's happening under the hood? Like, how does it go from your jumbled question into a perfectly crafted answer? What is that magic?
Well, it's not exactly magic, but it is brilliant. It really all boils down to just a few fundamental building blocks. I like to think of them as the Lego bricks of AI. Once you get these 9 core concepts, you'll have the toolkit to understand how almost any AI system is put together. So, let's start with that very first piece.
Okay, first up, let's tackle the most fundamental thing of all. How does an AI even learn to understand our language and then speak back to us?
So what's fascinating here is that neural networks, they can't read text like you and I do. They only understand one thing, numbers. So the very first step is always something called tokenization. Imagine you're chopping up ingredients before you cook. That's what this is. The text gets broken down into these little pieces called tokens, and each one gets a unique number. Only then can the model even begin to process what you asked.
Now, the most common way to do this uses an algorithm called byte pair encoding, or BPE for short. If you look at the slide, you can see how it works. It starts with just single characters, finds the most common pairs, like T and H, and then merges them. It just keeps doing this over and over, so common word fragments like ing or tation become their own super efficient tokens. It's a really clever way for the AI to build its own vocabulary from scratch.
Okay, so the AI has taken in your request. Now, how does it actually write a reply? That's where text decoding comes in. The model doesn't just spit out the whole response at once. Instead, it predicts the most likely next token, just one single piece at a time, building its answers step by step by step.
And when it's picking that next token, there are really 2 main strategies, as you can see in this table. The first one, greedy decoding, is the safe bet. It always picks the single most probable option. This is great for facts, but, it can get a little repetitive. The second one, top piece sampling, introduces a little bit of controlled chaos. It samples from a small group of likely options, which leads to way more creative, human-like responses. It's this fundamental trade-off, really, between being predictable and being creative.
So the AI can read and it can write, but the quality of what it writes, well, that often depends on us. And that brings us to the human side of the equation. How can we get better at talking to the AI?
This is where prompt engineering comes in. It's really the art of writing clear instructions to guide the model. It's all based on that old principle, garbage in, garbage out. If you give it a vague prompt, you're going to get a vague answer. The beautiful thing about this is that it's the fastest and cheapest way to get better results, because you're not changing the model at all, you're just getting better at asking questions.
And check this out. Here are 2 super powerful techniques you can use right away. With few-shot prompting, you just give the AI a couple of examples of what you want. It's perfect for mimicking a specific style. But for more complex stuff, like a math problem, you can use chain-of-thought prompting. You literally ask the model to think step by step, and that just dramatically improves its ability to reason.
Okay, so we know how to talk to the AI, but how do the developers make the core model itself better? Safer and more aligned with what we actually want it to do?
The key technique here is something called RLHF, or reinforcement learning from human feedback. This was a massive breakthrough and a huge part of ChatGPT's success. The best way to think of it is like teaching an AI good manners. It uses feedback from real people to learn what we find helpful and harmless. It pushes the AI beyond just statistically likely answers and toward answers that are genuinely useful.
And this slide shows you exactly how that feedback loop works. First, the model generates a few different answers. Then, as you see in step 2, real human raters rank them from best to worst. That data is then used to train a whole separate reward model that gets really good at predicting what humans will like. And finally, that reward model helps fine-tune the main AI. It's just a brilliant system for getting the AI aligned with us.
But look, fully retraining one of these massive AI models is incredibly expensive. That's where a technique called LoRA, or low-rank adaptation, comes into play. Think of it not as a full brain transplant, but more like precision surgery. It just adds small new layers to adapt the model for a specific task, without ever touching the vast original network.
And just look at the difference here. I mean, it's night and day. Full fine-tuning means updating billions of parameters. It's slow, it costs a fortune. LoRA, on the other hand, trains just a tiny fraction of that. It freezes that huge original model and only trains the small new layers. It makes creating specialized AIs vastly cheaper and faster.
All right, we've covered reading, writing, and training. Now let's talk about giving the AI superpowers, connecting it to the real world to expand its knowledge and actually let it take action.
So a standard AI is basically locked in time. It only knows what it was trained on, which gets outdated fast. RAG, or retrieval augmented generation, completely solves this. It's like giving the AI an open book exam. It connects the model to an external knowledge base, like your company's internal documents or even the live internet, so it can look up fresh information before it answers.
And the process is so simple but so powerful. You ask a question. The system goes out and finds relevant snippets from its knowledge source. Then, and only then, does the AI use those retrieved facts to formulate its answer. This grounds the response in real, current evidence, not just its old internal memory.
But what if you want an AI to do things, not just say things? Well, that's the whole idea behind AI agents. An agent basically gives the AI hands and feet by connecting it to tools like a web browser or a calculator. It can then plan a task, use a tool, see the result, and decide what to do next, all in this continuous loop.
So far, we've really focused on how AI understands and acts. For our final section, let's look at the most creative part, how AI can generate completely new things, like images, music, and even video.
Now, this whole process often starts with something called a variational autoencoder, or a VAE. A VAE is brilliant at learning the essential structure of data. It has two parts: an encoder that compresses an image down to its core features, its essence, and a decoder that can rebuild it. In modern systems, the VAE acts as this powerful compressor, letting the main creative model work much more efficiently in that smaller, compressed idea space.
And that brings us to diffusion models. This is the technology behind pretty much all of today's amazing AI image generators. The core idea is simple. It's about creating order from chaos. The model is trained to do just one thing very, very well: take a noisy, staticky image and predict how to clean it up just a tiny little bit.
So, to generate a totally new image, you start with pure random noise, like an old TV screen with no signal, as you see in step 1. Then, you repeatedly use that trained model to remove just a tiny bit of noise, over and over and over again. And as this process repeats, a clear, coherent, high-quality image slowly emerges from the static. It's actually an incredible thing to watch happen.
And there you have it. From tokenization and decoding, to prompt engineering and RLHF, to LoRA, RAG, agents, VAEs, and finally, diffusion models. That is your new AI toolkit. These 9 concepts right here are the foundation for nearly every single AI application you see out there today.
So now you have the building blocks. You can understand the AI of today. But here's a final thought to leave you with. What happens when these powerful tools start building the next generation of tools? That's when the future starts to get really, really interesting. Thanks for joining me for this explainer.
Thank you. Share and subscribe to Learn AI for more AI insights.